Hi, you guys. Welcome to our asynchronous lesson, our kind of review on the unit circle. I know it might feel like you have some whiplash. We just went from unit 5. We're not done with that yet, but I thought it would be a good idea to kind of warm up on the unit circle because it's going to be a big part of our learning in the next month. So, hey Salvador. I hope you guys are doing well. I hope you guys are staying safe. Like I said a couple weeks ago, your wellness is above everything for me. So I hope you're taking care of yourselves. Once you've taken care of your basic needs, go ahead and get started on this lesson. Okay, so with the unit circle, the reason why it's called unit is because it has a radius. Unit means 1, so it has a radius of 1. So in each direction, when we measure from the origin, right, this is our point 0, 0, every point here, this straight line that crosses every edge of the circle will have a radius of 1, right? I decided to be a little extra for this lesson and actually make my own unit circle. Of course, not in front of you because you know me in drawing circles, but I think that this is a good practice for you as well. I know how easy it is to Google a picture of the unit circle and use that, but for you to really understand what's going on, I highly recommend that you do draw out your own unit circle, kind of like how I did. So far on this unit circle, you see your angle measures in degrees and your angle measures in radians. Remember those fractions with the pi in it? That is in radians. And in degrees, remember you start on the right-hand side at 3 o'clock, right here. I'm going to draw a star. And then you go counterclockwise and you add your measurements that way. Now, if it's not very fresh to you, how to go from degrees to radians, that's going to be a part of your Delta math practice. So let's go ahead and practice that. But just remember, you go counterclockwise, starting on the right-hand side at 3 o'clock. So as you go from radians to degrees, it's important to remember kind of the big picture of it. One full turn, right, let me write that. One turn is 360 degrees, which is 2 pi. Therefore, 180 degrees is going to be half of 360, so it's also going to be half of 2 pi, which is just pi. So you are going to use the conversion ratio of 180 degrees to pi to convert from radians to degrees. I know I said degrees to radians before, but we're actually going to do radians to degrees. My bad. So you're going to use that conversion ratio. You want to cancel out that pi, so I'm going to put the pi at the bottom. I'm going to put my degree measure at the top. Then I'm going to multiply across. My pi's will cancel out. 180 degrees divided by 2 is 90 degrees. So pi over 2, therefore, is 90 degrees. If you check on our unit circle, you can see, boom, that is actually true. Nice. Let's do a couple more. You want to use that same conversion ratio, 180 degrees divided by pi. In this case, your pi's do cancel out. It's a little bit more efficient to divide first. So if you divide 180 degrees by 3, you should get 60. 5 times 60 degrees will give you 300 degrees. You can also multiply by 5 first. It's just more efficient to multiply by smaller numbers. So that's why I divided first. And you can take a look at your unit circle. 5 pi over 3 is right here, which is 300 degrees. Uno más, let's do one more. Same conversion ratio, 180 degrees divided by pi. Here your pi's cancel out. You get significantly larger numbers. Remember that 180 degrees divided by 4 is 45. So here you would get 3 times 45 degrees. And don't mind me here, just blanking. Pretty sure it's 135. Yep, it's 135 degrees. Cool. So once again, anytime you go from radians to degrees, use that same conversion ratio, knowing that 180 degrees does equal pi. All right, let's move forward. See how much more organized I am when I have time to pre-plan like this? Crazy. Okay, so you can see that I've added one more thing to our unit circle, and those are our most crucial coordinate points. Remember once again that your radius of a unit circle always is going to be 1. So the easiest coordinate points, I know you remember this, are going to be the ones at every end, every horizontal and vertical axis, right? So that's why your first coordinate point is 1, 0. Then you've got 0, positive 1, and these. From here on out, remember we base the unit circle on what we know about special right triangles, 30, 60, 90 triangles, and 45, 45, 90 triangles. You don't have to worry about the specifics of that very much. Just remember that these are how you come up with these coordinate points. The last thing I want to point out is your signs, meaning your positive and negative signs. Over here, in that first quadrant on the right-hand side, all of your coordinate points are positive. In the second quadrant, the first ones are just positive. In the third quadrant, both coordinate points are negative. And in the last one, your second one is negative. And I think I said the first is positive here. I meant that in the second quadrant, your first one is negative. Remember that these coordinate points also represent trig ratios. So in every single point, at every angle measure, your first coordinate point is cosine, right? Your x coordinate point is cosine, and your y coordinate point is sine. Tangent, if you're ever asked for it, is sine divided by cosine. You could build a whole triangle and find opposite over adjacent, or you can grab your y coordinate point and divide it by x as such. So go ahead and do some practice problems now. If you feel like I'm moving fast, don't be afraid to pause the video, but let's just keep it moving. So let's start with sine of 330 degrees. So first you want to find 330 degrees, hopefully on your handmade unit circle. At 330 degrees, I care about the y coordinate because we're talking about sine. So my answer will simply be -1/2. So what I did was I identified my angle measure. Check out the steps on the right-hand side. I identified the ratio I was looking for. I was looking for sine. And by ratio, I mean trig ratio. And then I need to either find it from the unit circle or simplify it in the case of tangent. For number 5, let's actually do a tangent. So you could see that tangent of 90 degrees is going to be right up top. It's going to be that 0, 1 coordinate point. Remember that tangent is sine over cosine. So I'm going to grab my second coordinate point and divide it by my first. Remember, and this is very relevant, very related to what we were just doing in Unit 5, if you divide by a 0, it will be undefined. So it's totally possible for you to have some undefined values in your delta math practice. Couple more. Cosine of pi over 6. Now I'm just asking you for the angle measure, but this time in radians. Pi over 6 is right here at 30 degrees. Cosine, so that's your angle. Cosine is that first coordinate point. So we're looking at √3 over 2. One more, tangent of pi over 6. So we're looking at that same angle measure. Remember that tangent is sine over cosine. So strap in for this one. It's going to take a second. Sine is your second coordinate point, 1/2. Cosine is your first coordinate point, √3 over 2. This is a mega fraction. We don't love that. So to handle this mega fraction, you are going to divide the fraction by flipping the bottom, finding the reciprocal of the denominator. So 1/2 stays the same, but instead of dividing, we're going to multiply, and we're going to flip this upside down. We're going to flip that bottom fraction upside down. See what happens. Your 2's cancel out, and you get 1 over √3. Now I've got another sad Miss Abdi, not because she lost power and water, but because there is a radical in the denominator. So to undo this radical, remember you multiply it by a version of 1. In this case, √3 divided by √3. What this will do is cancel out the radical in the denominator. So 1 times √3 is just √3. 3 times √3 will cancel out and just give you 3. So remember how to deal with mega fractions. You divide the denominator. You flip the denominator and multiply it. And to rationalize, to get rid of the radical in the bottom, you're going to multiply it by itself over itself. In other words, another version of 1. Cool. And that's that on that. So this covers all 3 sections of the Delta Math. I hope this was helpful. I will hopefully see you guys sometime the rest of this week. Love y'all. Be safe. Bye.